We're going to be solving equations with fractions or decimals in it today. So I've got this one, x over 4 equals 12. And typically when we solve this, we just multiply both sides by 4, so we can get a coefficient of 1 in front of the x. Multiply this by 4, multiply by 4, and this will cancel and become 1 over 1. And then we're left with 1x equals 48. And that's how we've done things. Another way to look at that is instead of it being x over 4, that's just the same as 1 over 4x equals 12. And so I can think a little bit more in terms of the coefficient out here. This is x times 1/4, so my coefficient is 1/4. It's a little easier to see that it's 1/4 this time. And so if I want to make that 1/4 equal to 1, all I have to do is multiply by its reciprocal, if you remember back. And when I multiply something by its reciprocal, then everything cancels. Obviously, the 1's would cancel and become 1's, but that's not going to help us. The 4's will cancel and become 1's. And so if I multiply the left side by 4 over 1, I also have to multiply the right side by 4 over 1. And so this, again, is 48. Just another way to look at to write that problem. So what happens if we have something like this? 2/3 x equals 14. So again, all I want to do is I want to make this here, this coefficient, equal to 1. Right now it's 2/3. So I'll multiply by its reciprocal, 3/2, and that will allow me to cancel the 2's and become 1 over 1, and the 3's, all of that becomes 1 over 1. So now on my left side I have x, and since I multiplied the left by 3/2, I also have to multiply the right by 3/2, and so this becomes, I can cancel this 2, becomes 1, and 2 goes into this 7 times, so we're left with x equals 21. Whoops, I forgot to box all my answers. Jeez. Okay, let's look at a few more here. So I'll show you a couple of ways to do this one here. We have 3/4 x minus 1/6 equals 1/6. And so I have to start, if you do this the way that we've kind of been performing these problems, I would start by adding 1/6 to both sides. Now thankfully, I have common denominators on the right, so that's just 2/6. And then on the left, all I'm left with is 3/4 x. I can leave that 2/6 as 2/6. I can simplify it to 1/3 if you want. It doesn't matter. They're the same value. So I simplified it to 1/3. So now all I have to do is get that coefficient equal to 1. So 3/4, the reciprocal of that is 4/3. So I'll multiply both sides by 4/3. And this stuff will all cancel and become 1 over 1. And so I'm left with just x on the left. And then on the right hand side, we just have 4/9. And that's as simple as we can write that. Now another way to do this, the same problem of 3/4 x minus 1/6 equals 1/6, is to get rid of what we don't like about this problem, and that is the fractions. So if I multiply both sides of that fraction, or of that equation, by the least common denominator here, I can clear my fractions and then just solve it as we normally would. Now, it's a little bit more work, but it does save some time, especially when you have to add or subtract fractions from both sides. If you don't have a common denominator, you have to get a common denominator anyways. This one was pretty easy to do. But let's just find our least common denominator. So 4 is 2 times 2, 6, 2 times 3. So our LCD is 2 times 2. I'm going to take the prime factorization of the 4. I'll compare it to the 6. The 6 has a 2. Do we have a 2? Yes, we do. Do we have a 3? No, we need a 3. So our LCD is 12, which most of us could tell just by looking at it. So what we'll do is we're going to multiply both sides of this equation by that 12. And you have to remember, when you multiply both sides, you have to remember that I'm multiplying this 12 by this and by this. And don't forget to do the other side as well. So what happens? The 12 times 3 is 36, and then divide that by 4, that's 9. Or you could cancel that 12 with the 4. So I get, on the left here, I get 9x, and then minus, and then 12 times 1/6. The 12 and the 6 will cancel, and you will get 2 equals, and then again, we'll get 2 over here. So now all I have to do, I have a nice simple equation with no fractions. Add 2, I get 9x equals 4, divide both sides by 9, and we get the same solution as we did over here. Okay, let's practice a few more where we're clearing our fraction. So this one, I've got 3 fractions here. So we'll find our LCD. So this is going to be, 4, 5, and 2. So 2 is prime, 5 is prime, and 4 is 2 times 2. So this, my LCD, I'll start with the 4. So we'll have 2 times 2. And then do we have a 5? No, we need a factor 5. Do we have a 2? Yes. So the LCD is 20. Okay, now we've got our LCD, so we're going to multiply both sides of this equation. Don't forget, you have to do both sides. So multiply that by 20, multiply that by 20. I'm going to be distributing this 20, remember, to here, to here, and to here. So 20 times 1/4 is 5. Whoops, forgot my color. So there we go. So I'll have 5m minus, and then 20 times 4/5. So the 20 will cancel with the 5, and we'll get 4 times 4, that's 16m. And then 20 times 1/2 is 10m equals, and then 20 times -1 is -20. So we'll combine our like terms here on the left. I'll have 5m minus 16m, that's -11m plus 10m. And then that's going to be -m equals -20. So I'll divide both sides by -1, get m equals 20. All right. Now what do we do with this? We got decimals in here. Oh my goodness. Well, think about what the decimals are. They're just another way to write a fraction, right? So this, even if we actually said this number here, if we said it properly, this is said as 9/10. This is 1 25/100. This is 75/100. This is 1 75/100. So I could rewrite these as the 0.9, that's 9/10. 1.25, that's 125/100. 0.75, 75/100. And 1.75 is equal to 175/100. So my LCD here is going to be 100, and so I could just multiply both sides of this equation by 100. So let's do that. So I'll multiply this by 100, multiply this by 100. So 100 times 0.9 is 90x. And then 100 times 125 hundredths is 125. Then this will be 75x, and then this will be 175. Much easier to work with now. And so I'll just solve as we normally would. We've got variables and constants on both sides. So I'll just start by adding 125 to both sides. So this should be 300. Still have the 75x. And we have a 90x there. Subtract 75x from both sides. This is 15x. And now we just have to divide both sides by 15. So we should get x equals 20. This is the last one of our fantastic, fabulous example problems here. This one looks kind of messy, but still our purpose is to try and cancel out these denominators here. And so when you look at this, we can tell that our LCD would be 8. So we'll just multiply both sides of our equation by 8. Don't forget to include that plus 1 there. So multiply that by 8. I'm going to multiply this by 8. And so when we multiply through, the 8 and the 2 here, these guys are going to, this 2 will cancel with that 8. And you'll be left with a 1 in the denominator, and then this will be a 4. So it'll be 4 times 3x plus 4. And then I have to distribute the 8 to the 1, so that'd be plus 8. And then over on the right-hand side, the 8s are going to cancel, and we're just left with 5x plus 10. So we have a little bit of simplifying left over here. So this is 4 times 3x is, we're going to have to distribute that 4 in, so this will be 12x plus 16 plus 8 equals 5x plus 10. And then we'll have 12x. I'm going to add the 16 and the 8 together. 12x plus 24. And I'm going to subtract the 5x from both sides, get all of our variable terms on the left over here. So now I have that. And we'll subtract our constant away from the variables. So now we have 7x equals negative 14. Divide both sides by 7. And we should get x equals negative 2. And then, of course, plug it back in and check to make sure that you got it correct. All right, that's the end of this one, so we'll talk to you guys later.